So this is lesson 6 in the quant chemistry. This is mostly the higher tier work. So this is building on the mass conservation idea and using the idea of mass conservation to then work out how much product you should make. Okay, because I've told you that before that you can't make atoms appear or disappear. So whichever atoms you have making mass on one side of the equation, you have to have the same amount of atoms on the other side of the equation. So you should be able to work out how much mass is in each of the products. And from that you can also work backwards to a balanced symbol equation. But I guess one of the things I want you to think about is where do the atoms that make up you come from? So you're made up of an awful lot of oxygen, hydrogen, carbon, a little bit of sulfur, a little bit of phosphorus. Where do those atoms actually come from? So you are mostly made of oxygen, hydrogen, carbon, nitrogen, sulfur, phosphorus. But those atoms that go to make up you have come from somewhere, and they come from the food that you eat. So where does the food you eat come from? It comes from ultimately your primary producers, which are your plants, a little bit of biology in there, who are making sugars using the energy from the sun, and they're using carbon dioxide and water to make sugar out of it. So that carbon dioxide and water is sort of been around, going around the Earth since the creation of the Earth, which is I don't know how many billion years ago, I always forget. And where those atoms come from in the beginning, from the Big Bang. So the atoms that make up you are ultimately, most of them are as old as the universe, or thereabouts, so they just get recycled. So the idea of mass conservation links back into the fact that, you know, all these atoms just keep doing a little merry-go-round, so they start some place and they end up in another place. They don't disappear. So what we looked at earlier on was, we said, in this example here, this is a physical change where we've got ice melting to water. So you have the same amount of atoms in your ice as you do in your water, and so they will have the same mass. And in lesson 4, we also talked about this experiment, which is adding magnesium to acid. And remember that we said that when magnesium reacts with acid, the mass decreases. Okay, this is because the gas escapes. However, overall mass is conserved. Okay, so because you have Mg plus HCl usually going to MgCl2 plus H2. Okay, so you have to have one atom of magnesium reacting with 2 formula units of hydrochloric acid to give you 1 formula unit of MgCl2 and 1 of H2. So this is the kind of question that you're going to get asked in this topic. What mass of magnesium oxide is produced when you burn 60 grams of magnesium in air? So the first thing you have to do is you have to have a balanced symbol equation. So hopefully you should be feeling a little bit more confident on these for now. So magnesium plus oxygen always goes around as O2, remember? And the formula for magnesium oxide is MgO, which you should have learnt from your ionic formulae section. You've got 2 oxygens on this side, 1 on this side. The only way you can increase those is to put a 2 in there and a 2 in there. That is your balanced formula equation. Step 2 is, I would like to think about this a little bit in terms of atoms to start with. Okay, so you know that, I'm just going to put this up in the top corner, that we've got 24, 12 Mg, I've got 16, 8, O from the periodic table. So if we have 2 magnesiums, the mass of those 2 magnesiums is going to be 2 times 24, which is 48. Okay. The mass of those oxygens is going to be 2 times 16, 16 because that's the mass of a single oxygen, so that's going to be 32. Now the mass of magnesium oxide in this case, we need to take the 24 plus the 16, okay, which give me 40, but there's 2 times that, so we're going to make 80. Oops. So that's just by adding up your relative molecular masses. But what you can do is, this should actually, well, let me just point out one thing first actually. If you add 48 plus 32, it actually equals 80. Okay, so this is proving the idea of mass conservation. What we've got on one side of the equation is what we've got on the other. So my next assumption now is that 48 grams of magnesium plus 32 grams of oxygen will give me 80 grams of magnesium oxide, okay? But we need to burn 60 grams of magnesium. Now we've got 48, so to work out what we want to do is 60, you need to divide that by 48, divide that by 48, divide that by 48, and multiply that by 60. 60 times 60. Okay. So, imagine here now cancelling this out. 60 grams of magnesium. I'm just going to ignore the oxygen because it's not asking for it in the question. Will give you 80 times 60 divided by 48 grams of magnesium oxide, which turns out to be 100 grams of MgO. So that's one way of thinking about it, is to actually think about atoms. What you could also do is think about this in terms of moles. Because what this equation is also telling you is that you've got 2 moles of magnesium will react with 1 mole of oxygen to give me 2 moles of magnesium oxide. So at this point then, you can jump straight to this step here. So 2 moles of magnesium weigh 48 grams, plus 1 mole of oxygen molecules, we learnt in the last lesson was 32 grams, and 2 moles of magnesium oxide. Okay, so it's 24 plus 16, going to 40 times 2, 80. So it's kind of jumping straight to moles. Sometimes, just to kind of explain it, first time thinking about it, I would actually think about a molecule, but you should be starting to work in moles. We'll do another example. So for this next example, what mass of hydrogen is produced by electrolysis of 6 grams of water? So the first step was always to give yourself a balanced symbol equation. Now you probably haven't come across this idea yet, but when you run electricity through water, it will produce hydrogen and oxygen gas. Okay, so we have to produce an O2, so we're going to have a 2 in front of this one, which means we need to make a 2H2 there. So let's think about what this equation means. This equation is telling me that 2 moles of water produces 2 moles of hydrogen gas and 1 mole of oxygen gas. So we know that the mass of 1 mole of H2O is 16 plus 1 plus 1, 18. We know that the RMM of 1 mole of H2 is 2 grams. Okay. So what this equation is telling us is that 2 moles of water, so that will be 36 grams of water, gives us 2 moles of hydrogen. 2 times 2 is 4 grams of hydrogen. Now we want to work this out for 6 grams, so that's pretty straightforward. You divide by 36 on each side, and then you multiply by 6 on each side. Okay, so this will cancel out. So 6 grams of water gives you 4 6 are 24 over 36 grams of hydrogen. Okay, so we're going to be able to work that out as being something smaller, 2/3 of a gram of hydrogen. So the spec's also asking you to do something a little bit different this year, which is deriving a balanced symbol equation from the number of moles. So they're going to tell you a certain number of moles produced, or a certain amount of substance is produced. You need to work out how many moles, and from that infer a balanced symbol equation. Okay, so we are burning 4.8 grams of magnesium in 3.2 grams of oxygen, and we're getting 8 grams of magnesium oxide. Okay, so we need to work out how many moles of each of these we have. Okay, so you remember we had our mass equals mR times mole, mass equals Mr. Mole, Okay, and we're going to rearrange that to work out the number of moles. So moles equals mass over mR, because we've been given the mass each time. Okay, given the mass. If we divide it by the mR, which we just get straight from the periodic table, it will tell us the number of moles. So the trick is to divide that by the relative formula mass of magnesium, which is 24. Divide that by the relative formula mass of oxygen, which is 32. And divide that by the relative formula mass of magnesium oxide, which is going to be 24 plus 16, which is 40. I'm just going to explain why it's 24 plus 16, 24, 12 magnesium, 16, 8 oxygen, just to remind you. So, here's your number of moles, and I can see I've worked them out here, okay? So what it's telling you is that you have 0.2 moles of Mg plus 0.1 mole of O2 gives you 0.2 moles of MgO. Now, if you divide by this, by the smallest whole number, you get 2 Mg plus O2 gives you 2 MgO, which is your balanced symbol equation. Hopefully that makes sense.